All right, how many of you have ever been snow skiing, snowboarding, anything like that? Snow skiing, snowboarding, anything like that. Okay. So when you go skiing, you have slopes, right? Okay. They classify the mountains by the steepness of the mountain. So you have like the bunny slope, and you've got like the black diamonds that are really steep and have all the terrain and the moguls and that kind of stuff, right? So the same way that we use slopes to classify the steepness of a mountain, we use slopes as a way to measure the steepness of our lines. It's the same idea. So we could classify slope with lines quite a few different ways. We think of it as the change in y over the change in x. We think of it as y2 minus y1 over x2 minus x1, rise over run, opposite of a over b. Lots of different ways that we can look at that. The most common mistake that people make is they forget that it's the y values on top and the x values on bottom. You must rise before you run. Rise over run. So for example 1, they give me 2 points and they ask me to calculate the slope. We're going to label these the exact same way that we did for distance and midpoint, where we could go through and we could say, okay, if this is point number 1, we'll call this the x value for point 1 and the y value for point 1. If this is point number 2, we'll call this the x value for point 2 and the y value for point 2. Okay, so we could go through then, and using our formula, we could say y2 minus y1, so that would give us 0 minus 1, and then x2 minus x1, so negative 2 minus 3. So what's your slope going to be? 1 over 5. You could say negative 1 over negative 5, but we would simplify that down to a positive 1/5. Look at those 2 points that we have plotted down here, those same 2 points, negative 2, 0, and 3, 1. If we start at negative 2, 0, and we rise a positive 1, and we run a positive 1, 2, 3, 4, 5, we get to the next point. And we could continue that same thing. We could start here at 3, 1, and we could rise 1 and run 5, and that would put us at the next point on the line. We also said that this was negative 1 over negative 5. If you start at 3, 1, and you rise a negative 1, and you run a negative 5, 1, 2, 3, 4, 5, that would put you back at the other point. And you could keep going that same way as well. Rise a negative 1, run a negative 5, and that would give you another point on that line. Okay? So that's how that slope is a way of measuring the steepness of that line and helping us find the relationship between those 2 points. All right, so go ahead and calculate the slope on these next 2 that they gave us. So for your second one, you got 0 over 3, and if you divide 0 by anything other than 0, you're going to get 0, right? All right, think about that for just a second. If you took those 2 points, negative 1, 2, and 2, 2, and you graphed those, you're getting a rise of 0 and a run of 3. So if I start at this point and I rise up and down 0 and I run forward 1, 2, 3, a positive 3, yeah, I'm going to be at that other point. So that makes sense. And I could keep going with that same idea, rise 0, run 3. That's going to give me a horizontal line, right? So anytime you have a horizontal line, it's always going to have a slope of 0. If we go back to our skiing analogy, that's just the bunny slope, right? It has 0 degrees of inclination. It's kind of like when you were in geometry and you worked with those protractors. Remember on your protractor, if you had to measure something, the very starting place was at 0 degrees. Because if you've got a flat line and you're starting, it has 0 degrees of inclination. Yeah, if you go all the way around, it's 180. But starting, it's 0 degrees of inclination. So horizontal line is going to have a slope of 0. All right, what'd you get for your third one? Undefined, right, because you got 0 in the denominator. Division by 0 is undefined. So you could say undefined or you could say no slope. Those two are synonymous. So on your quiz tomorrow, if you were asked to find the slope and you had one that was like this and you said, okay, my slope is undefined. If you're looking at the choices and one of the choices is no slope, don't put none of these, because no slope and undefined are the same thing. Or the converse of that would be true. If you're looking for no slope and I have undefined listed as one of the answer choices, don't put none of these. You need to understand that no slope or undefined mean the same thing. They're interchangeable. So if you graph those 2 points, you've got 3, 4, and you've got 3, 1. So if I graph those 2 points, they make a vertical line. So every vertical line has no slope. Again, go back to our ski analogy. Can you ski that? That's not a slope. That's a stinking cliff, right? Don't go there. So you can remember 0 degrees of inclination, horizontal line, 0 slope, like the bunny slope. You can remember vertical line, undefined, no slope. That's a cliff. You can't ski it. Okay? All right. So then we talk about different forms of lines. We've got general form or standard form. They'll again use those 2 words interchangeably. Point slope form and slope-intercept form. All right, standard form. A, B, and C have to be integers. So that means no fractions, no decimals. Everything over on the left-hand side set equal to 0. A and B cannot both be 0 at the same time. One or the other, but not both. Then we've got point slope form. So that you need a point and a slope. And slope-intercept, you need the slope and the y-intercept. M is your slope, B is your y-intercept. So in example number 1, they give me a point and a slope, and they ask me to create the equation of the line. So I would tend to think I should use point slope form. So I'm going to use point slope form right here. All right. So I'm going to go through and plug in what I know. I have 1 point, so this is x1 and this is y1. So let's put in -2 for y1, and let's put in the +1 for x1. And of course our slope was -2/3, so let's put that in. We could do a little bit of simplifying with the minus and negative and make it a plus, but if they ask me to give my answer in point slope form, there it is. Usually they're going to ask me to give my answer in standard form, so I'm going to need to keep simplifying. So I'm also going to need to distribute this -2/3 over here to everything in parentheses. So that would give me -2/3 x and a +2/3. If it's in standard form, I need everything on the left-hand side set equal to 0. Because standard form was ax plus by plus c equals 0. So let's move it all over to the left-hand side, set equal to 0. One last thing I have to do to finish standard form. What is that? Yes, get rid of the fractions. So I'm going to multiply everything by my least common denominator of 3 and clear out my fractions. So there's my equation in standard form. Now that is probably the way that you have done it all of your algebraic life. And you are welcome to do it that way. But there is a much faster, easier way of doing that. So if you want to stick with the other way and just put your fingers in your ears and don't listen, but if you're one of those, hey, if there's a faster, easier way to do it, I want to know what that is, let me propose this to you. One of our definitions of slope is that it is the opposite of A over B. So if they told me that my slope was -2/3, if you match this up, the negative matches up with the negative, A would have to match up with 2, and B would have to match up with 3. Standard form is ax plus by plus c equals 0. If I put 2 in for A and 3 in for B, look how close I am to my final answer in my first step. I haven't had to do any work yet. So I've used my slope, I haven't used my point yet, so let's use that point. If I plug the 1 in for x and the -2 in for y, that would tell me what c was and I'd be finished. Some of you can do that in your head and you wouldn't need to even write anything down on your paper. I wrote it out just so that you could see it, but you'd be welcome to, in your head, say 2 times 1 is 2, and 3 times -2 is -6, so 2 and -6 is -4, so -4 and what? Oh, that means c would be 4, and you're done. Again, we wrote it out here so that we could see it, but if I take that 4 and I bring it back up here and I put it in the place of that c, that is the exact same standard form we got over here, but a much faster, easier way of doing it. I don't care which way you do it. You're welcome to use point slope form, or you're welcome to use that. You're welcome to experiment with both of them on the homework and just see which one you like better. They'll both lead you to the same answer. All right, look at the next one. For the next one, instead of giving me a point and a slope, they give me 2 points. What do I need? A slope, yeah. So I'm going to do the same thing that we were doing up here early on in the lesson, where if we had 2 points, we found the slope. So I'm just going to use my slope formula. I'm going to go through and say y2 minus y1 over x2 minus x1 and get my slope. All right, now I have a slope. Now what?
Try one of the way.
Yeah, I could use one of those points and use one of those two methods that we were just looking at. It does not matter which point you choose. I picked the first one there, 1, -2. They just asked me the exact same question that they did in the previous example. They just asked it a different way. Because if you'll notice, now I have a point, 1, -2, and I have a slope, -2/3. And that's exactly what we had in the last example. So from there, you could choose either one of those two methods to create the equation of your line. Another way that they might pose this to you is they might give you the points in a word problem form. Like example 3, it says during 1997, Barnes & Noble's net sales were $2.8 billion. In 1998, their net sales were $3 billion. So write a linear equation giving the net sales Y in terms of the year X. Okay, so they want me to create a linear equation given 2 points, is all that is. I could go through and take that information and say in 1997 it was 2.8, in 1998 it was 3.0. That's my 2 points. Just like back here when we had 2 points, we needed a slope. I would do y2 minus y1 over x2 minus x1 and get a slope. And then I could choose either one of these points. I'd probably choose the one with the whole number instead of with the decimal. But I could choose a point and a slope, and either one of those two methods that I want to create the equation of my line. So no matter how they pose it to you, I'm still going to work it the same way. All right, look at example 4. For example number 4, it asks us to determine the slope and the y-intercept of each linear equation. Okay, slope and y-intercept, that pretty much leads me to think of slope-intercept form. So if you look back at the top of your notes, slope-intercept form, you've got y on one side by itself, everything else on the other side. So let's take this equation and let's get y on one side by itself, everything else on the other side. So I'm going to subtract my x over and add my 2 over so that it's in slope-intercept form. All right, so slope is the number that's in front of x. So what's the number in front of our x? -1, so that's my slope. Your y-intercept is just your constant over here, so what's our y-intercept? A +2, right. So I'm welcome to do that, but I have to, if they give it to me in standard form, I have to convert it over to slope-intercept form. Here's another one of those things that you don't necessarily have to do it that way if you don't want to. You don't need to write this down, but if I took standard form, ax plus by plus c is equal to 0, and I switched it into slope-intercept form, meaning I solved for y, right? If I'm going to solve for y, I'd have to move the ax to the other side, and I'd have to move the c to the other side. All right, so I'm going to subtract the ax over, and I'm going to subtract the c over. Now I got to get y by itself, so I would divide everything by b. So divide by b, divide by b. If you line that up with slope-intercept form, slope is the opposite of a over b, and the y-intercept is the opposite of c over b. If I recognize that if they give me an equation in standard form, I don't have to convert it to slope-intercept form to be able to tell what my slope and my y-intercept are. Let's go back to that same example that we just had. We just had 1x plus 1y minus 2 equals 0. Okay, so there it is. 1x plus 1y minus 2 is equal to 0. So a is equal to 1, b is equal to 1, and c is equal to -2. If slope is the opposite of a over b, I literally could look at that equation in standard form, not need to switch it to slope-intercept form, and be able to say, okay, the opposite of a over b. A was 1, b was 1, my slope is -1. And that's the same thing as what we got up here. We said that the y-intercept would be -c over b. So again, I could look at that and I could say, okay, c was a -2, b was a +1. So -c over b would give me a +2. Same thing we got up there. So you're welcome to, if they give it to you in standard form, you're welcome to switch it into slope-intercept form. No problem with that. But you also can look at it in its standard form and not have to change it and be able to see what your slope and your y-intercept are if you know what those two formulas are. Okay, so again, just options. I don't care which way you do it. I just like to present you with options of ways that you can do it and show you the reasoning behind why you're able to do that as well. All right, look at the next one. The next two that they give us are a little trickier. For the next one, they give me y is equal to 2. And so I look at that and I'm like, okay, so my slope is the number in front of x. I don't have an x. Okay, well maybe we should try graphing y equals 2. What does y equals 2 look like when you graph it? Horizontal line, and in this case, because it's y equals 2, it's going to be a horizontal line through 2. If you ever have trouble keeping that straight, like, okay, I know it's a horizontal line or a vertical line, but I can't remember which one it is, it always has to cross over the axis that it's equal to. This is y equals 2. If it's y equals 2, at some point, it has to cross the y-axis and be equal to 2, right? So it would cross the y-axis if it was horizontal. So there's what my graph looks like. We talked earlier today about every horizontal line has a slope of what? 0. So, okay, I answered the first question then of what my slope would be. And then where did this cross my y-axis? At 2. So there's my y-intercept. Now, I think I could make a case for, okay, I could rewrite this equation as y equals 0x plus 2, and I'd be able to see 0 is the number in front of x, so that's the slope, and 2 is my constant, so that's my y-intercept. But I don't see any kind of argument for how you could look at this equation and be able to see the number in front of x and get the right slope, and be able to see the constant and be able to get the right y-intercept. Because if I looked at this, I would be tempted to say the number in front of x is 1, so that's my slope, and then I got this constant over here, so that's my y-intercept, and neither one of those is correct. So instead, let's treat this one the way we did the last one. Let's think about the graph. What does the graph of x equals 2 look like? Vertical line going through 2. So again, if it's going to be x equals something, at some point it's got to cross the x-axis, right? So x is equal to 2. We said that every vertical line has a slope of what? Undefined or no slope, right? You could say it either way, either undefined or no slope. And where did it cross the y-axis? It doesn't, so it doesn't have one. You're not going to get that from that equation, okay? So just a little helpful reminder, horizontal lines always have the equation y equals something and a slope of 0. Vertical lines always have the equation x equals something and no slope, okay? So here is our homework for tonight. On pages 33 to 36. We do have our first quiz tomorrow, so be sure that you look over your quiz policies to make sure you don't have any questions about those. Our quiz is P1, P2, and the first half of P3, so just where we stopped today. You need to be sure that you bring a scientific calculator with you for your quiz tomorrow. On our policy sheet, it said you're supposed to have a scientific and a graphing with you every day, but you surely want to be sure that you have it with you on the day of a quiz or a test. You will not be using a graphing calculator for this quiz tomorrow, so if you want a calculator, it must be scientific. So be sure you bring a scientific with you for tomorrow.